Hello, welcome to Topper Machine. I'm Josh Topper, and if you saw Saturday's video, you saw me make that spindle for an ASV skid steer. A really simple, straightforward job, but I had a lot of really good questions that I'm going to address in this video here. So one of the most common questions I got was based on my material choice to make that new spindle. Why did I choose to use that chunk of 1045 TG&P that I had laying here? Well, that's a simple one. For many years, I've made many different spindles for many different companies. One was a repeat job for years until the company went out of business, and that was building spindles for a towable asphalt roller. So they had drop-down arms, and the owner of the company ran the place into the dirt. 150 years of business gone, just like that. So sad story there, but all of the drawings for the spindles on different machines called for either 1045 or 1144 stress proof. Those are the choices that we've always made them out of. It's very rare that you ever see anything out of 4140, 4340, anything like that. I have never seen one made that way, so that's why I chose to use the 1045 that I had here. 1144 stress proof would have been another excellent choice. And as far as heat treating, somebody asked about heat treating. I have never seen a spindle heat treated in my life. I've never seen one truly hard, because your taper bearings are just sitting there and they're compressed by the nut. They're not turning, the bearing is. So the race gets pounded into the mating piece, the bearing slips onto the shaft, there needs to be a little give there, and you tighten it up. And that's all there is. So it really doesn't need to be hard. It just needs to be a very close fit so that it can't move. A couple more questions I had was why I didn't use a radius cutter. Why would I? I've been doing this so long that I can hand cut a radius like you saw in the video. There's no need to switch out tools if you got the practice. You know, I've been doing this 25, 26 years, and I've started out using radius cutters. If it's a radius that absolutely has to be perfect, yes, I'll use a radius cutter, but with experience, you really don't need one. And you just take it slow, feed it in gently, and it's not a big deal. Somebody suggested button inserts. You know, them round inserts are great, but there's so many different sizes of holders you would need. I have a couple of different ones, but I use them for specific things. So again, they wouldn't work at all there. I would have to spend a ton of money just to get every size there is. And again, round inserts, you know, they're expensive, the tooling's expensive. It's just not worth it to me to spend that kind of money. Another good question was about shrink fit. Why we didn't make that to shrink fit into that arm? Well, that one's a very good question, and actually there is a good reason why it isn't. And it wasn't from the manufacturer either. But the reason is how do you get that perfectly straight without all kinds of fixturing? So my customer has to put this back on his machine in place. So what he's going to do is take that spindle and assemble it into the housing that it goes to get that lined up. And then he's going to put that arm, get that arm up there on the axle shaft and on the spindle, and then tack weld it all so that he can get it to hold true. And he may just weld it up as is if he can get to both sides. So a shrink fit would never guarantee a true straight fit. That's why we did it a little sloppy. We did it a lot tighter than the factory original. The factory original was like 20 thousandths looser than the one I did. So we put it a little bit tighter, a little closer, and he hasn't called yet and said, hey, we need to turn that down, so we must have done it right. I'll be talking to him soon anyway, just see how he did, but he was going to do it over the 4th. So I haven't heard yet, but I'm hoping he's got his machine back together. This guy is one of the leads for one of my customers. He's very, very skilled, good welder, good, mechanic. So great guy all around. I like working with him, and I'm just glad I was able to help him on this job. So the last question I want to address is the one about why there are jobs I can't film and what designates the jobs I can't film. The jobs I can't film are the jobs that either A, are proprietary, they're the customer's, own equipment they're designing for their own facilities, and they don't want that information getting out, and there's quite a bit of that I do. So they're designing the equipment for the process they're doing that their competitor doesn't have. So it's something we don't want to share. Another one is the customer specifically outright asks me not to share it. I get some of that occasionally. There's other jobs where I have the customers that are like, hey, go ahead and film this. Do not show our name. Do not show the final product. Do not show, you know, this and that. And that's fine. That's great. But it's a lot of it is up to the customer of what I can and can't film. So I got to be mindful of the customers. I don't want to lose the customers, upset them, or get sued. I mean, that's an option too. And nowadays, a lot of my customers I have NDAs with, so it's kind of a gray area. So a lot of the work I do it's all over the place. It's all kinds of weird stuff, and that's just it. We can't film everything. Some we can, some we can't, and that's just the way it's going to be. You know, my comment when we were filming that spindle, why I was doing it in the Monarch, is because the Lion was set up with a job that I couldn't film, proprietary stuff. That was entirely the case. That's why we did it over in the Monarch. And quite honestly, the Monarch is a little bit easier to run as far as the threading goes. The Lion is great for a lot of stuff, but the threading is a little awkward. I've gotten used to it. It works great. It does metric threading, diametral, all of that. So it's a great machine all around. But in that instance, it was set up for a proprietary job that I just could not show. So I hope that answered all the questions. And with that, until next time, get out in your shop and get it done right the first time.